All right, page 505 in your textbooks, and we are looking through some final exam review. We have some quick questions I want to run through here at the bottom of page 505. Number one, what kind of angles do perpendicular lines form, class? Right angles. Right angles, or 90-degree angles if you prefer. You can be jotting these answers in real quick. What's the name of an angle that has a measurement of exactly 180 degrees? Kirsten?
Reflex?
Not a reflex angle. It's bigger than 180. We call it a reflex angle. Jalen, feet down.
Straight angle.
Straight angle. Because remember, 180 degrees, the sides are perfectly straight line with each other. Well, there we go. Number three, Kirsten. What kind of angle has a measure between 180 degrees and 360 degrees?
Reflex.
Reflex angle. There it is. Number four. What's the name for any quadrilateral? Whoa. Hold on now. Quadrilateral. What does that mean? What does that word mean, Michael?
It has 4 sides.
It has 4 sides. Okay, so we're picturing something with 4 sides whose opposite sides are parallel. A quadrilateral whose opposite sides are parallel. Joel?
Rectangle?
A rectangle would be one of these, but that's too specific. Because remember, a rectangle has to have perfect 90-degree angles. You could have parallel sides without perfect right angles. They could be slanty. And it would still have opposite sides parallel. In fact, we worked the word parallel into the name. Ben?
Parallelogram.
A parallelogram. Now, you're not necessarily wrong with rectangle, Joel, to be clear, but parallelogram is the better answer. Rectangle is almost too specific there. Let's see. How would I use notation for line XY is parallel to line WZ? Bryson, do you remember?
Oh.
The symbol for parallel. Corey?
X, Y equals WZ.
Not equals WZ. We want the symbol that means parallel. Kirsten's back there motioning.
The 11.
It looks like an 11. It's actually 2 parallel lines. So line XY is parallel to line WZ. So there's your notation for parallel. Number 6, what kind of angles are formed when 2 lines intersect? Now for this, it might help if you actually drew a set real quick. If we drew these lines, these 2 angles, for instance, they're equal to each other. Do we remember what we call them? Corey, for redemption?
Adjacent.
Well, actually, these 2 would be adjacent, or these 2 would be adjacent, but the ones that aren't adjacent are called?
Acute.
Well, these happen to be acute angles, yes, but they have another name. Ben? Not adjacent. Well, no, that's not the term for them. Michael?
Vertical.
Vertical angles. Yeah, vertical angles. Go and write that term in your notes. Vertical, or in your book there. Vertical angles. Because, again, if you looked at it from this perspective, they're stacked on top of each other. They're vertical to each other if you rotated the picture. These 2 are vertical to each other. They're on top of each other. What is the name for any rectangle? So picture a rectangle that has all 4 sides equal. What's the name of a rectangle that has all 4 sides equal? Here you go, Joel. A square. There you go. Number 8. What is the sum of the angles of a triangle? Obviously, we know a triangle has how many angles, class? 3, hence the name triangle, tri meaning 3. But if you added the 3 angles together, what will it always add up to, Elaine?
180.
180 degrees. 180 degrees. Number 9. If angle P is 37 degrees, what type of angle is it? What type of angle would be 37 degrees? Griffin?
Acute.
An acute angle. Anything less than 90 is an acute angle. Looking at the next one, they ask for the supplement of an angle. They say if Y and W are supplementary angles. An angle Y is 67 degrees. It says, what's the measure of angle W? Well, supplementary angles. What do we need to remember about supplementary angles, Bryson? Add them together to get, add up to 180 degrees. Excellent. So we need to make sure we know that supplementary angles add up to 180 degrees. So if the first angle, angle Y, is 67 degrees, how many degrees are still left for angle W? Finding it at your seats. And a few of you already have it. Jalen? 113 degrees. How did you find that?
I subtracted 67 from my 8.
Good. 180 minus 67 degrees to give it to you. Okay. Now on number 11, we see another term, the complement. Well, what do we need to remember about complementary angles? Luciana?
They're equal to 90 degrees.
They add up to 90 degrees. Okay, so then looking at number 11, it says what's the complement of angle M if angle M is 65 degrees? What would be the complement of angle M if M is 65 degrees? Michael?
Oh, 25 degrees.
25 degrees. How'd you get that?
I subtracted 65 from 90.
Good. 90 minus 65. Question?
I just wanted to do, I just wanted to do.
Ah. All right, number 12. If the diameter of a circle is 4.2 feet, what's the circumference of a circle? Class, what does circumference mean?
Distance around.
Distance around a circle, right? The distance around a circle. And we actually have two different formulas for circumference. What's one way to find circumference, Michael?
Pi r squared.
Ooh, no, not pi r squared. Luciana,
2 pi r.
2 pi r is one way to find it. What's the other way we could find circumference besides 2 pi r?
Pi r h.
Not pi r h.
Pi r d.
Oh, see, this is why I had you copy formulas last night. Try to jog your memory.
Pi d.
Pi d, there we go, pi times diameter. So specifically focusing here on the pi d, if we know the diameter is 4.2 feet, to find the circumference, class, you just multiply by 3.14. Or you could multiply by, anyone, what's the other approximation of pi?
27.
22 sevenths. And think about it. What's the diameter they gave us? 4.2 feet. Put that over 1. 7 can cancel with a 42 to give us a 6. In this case, a 0.6. And now 0.6 times 22 is even faster than multiplying 4.2 by 3.14. Either way, we could multiply. We'd either get 13.188 feet approximately, or we could end up getting 13.2 feet approximately. Either answer would be correct for 12. Number 13, they give us a radius of the circle, and they say, what's the circumference? Well, if they give us a radius, class, we want to use the formula
2 pi r.
C equals 2 pi r. We'd multiply the radius times 2, and then times pi. Or pi times 2, and then multiply by the radius. The answer, just if you're curious, write this down, is approximately 70.65 yards. If you know the formula, you're going to be okay. We'll, for sake of time, move on. Number 14. If the angles of triangle ABC are 45 degrees, and 90 degrees, what kind of triangle do we have? Ben?
And equilateral.
Not equilateral, but you're close. Not equal angular, because all three would have to be equal, right? There's 45, 45, and 90. So not equilateral or equiangular.
Is it the
Isosceles. It would end up being isosceles. That's not even what the book is looking for. But with a pair of 45s, you would have isosceles. Two sides, Ben, would be equal. But what they're keying in on is the 90-degree angle, class. If it's got a 90-degree angle in it, it's a right triangle. And by the way, the three sides could be related through the Pythagorean theorem, because it's a right triangle. So that's what they were shooting for, was right triangle, but it is isosceles, actually. Speaking of which, number 15, how many equal sides do you have an isosceles triangle, class?
2.
2. What about to have equilateral?
3.
You'd have to have all three equal for equilateral. Turn the page. Number 16, if we have a right triangle, and angle U is 40 degrees. So we have some right triangle, and we have an angle that is 40 degrees. What are the measure of the other two angles? Well, one of them should be obvious, class. If it's a right triangle, one of our angles has to be 90 degrees, right? But then the other one, what do we remember about the three angles? They add up to 180. So how many degrees are still sitting there for that top angle, Joel? 50 degrees still remaining for that top angle. Number 17, real quick at your seats. The radius of a circle, if we know the diameter, is 8.6 inches. The radius of a circle, if we know the diameter, is 8.6 inches. Find it quickly, and then we'll get our answer from Elaine. Better be able to get it from Griffin.
4.3.
4.3 inches, just cut it in half. Remember, because the radius is half of the diameter. How many of the 4.3 inches? How many blanked on what the difference was between radius and diameter? Diameter's all the way across, radius is halfway across. A circle has 4 central angles. For instance, look at number 20, class. You see there's 3 central angles in that circle there. What do we know about all the central angles of a circle? What do they have to add up to, class?
360.
360. Okay, so going back to number 18 now, 4 central angles. 23 degrees, 158 degrees, 82 degrees. At your seats, find the 4th angle. At your seats, find the 4th angle. Bless you. And what is that last angle going to be here? Just trying to give Elaine some redemption. All right, Elaine, you got it?
97 degrees.
97 degrees. How many had 97 degrees there? Good job in the back. All right, questions on those problems? Even if you didn't have time to finish it, do we understand what to do if we saw a similar problem on the exam tomorrow? Yes, sir.
I'm just curious, for 16, could you make an equation for that?
I mean, you could say u plus 90 plus x equals, or 40 plus 90 plus x equals 180 degrees. I mean, you could. Yep. All right, drop down to number 21. We're not going to take time to work all of these, but it asks for the perimeter of a parallelogram. And it tells me that one of the sides of the parallelogram is 19 centimeters, another side is 26 centimeters. How would I find the perimeter of a parallelogram? Michael?
P equal base times height.
Well, that's the area of a parallelogram, but the perimeter, the distance around a parallelogram, what would I have to do? If we know one side A is whatever and one side B is whatever. Jalen?
Plus C equals PH.
No, this is the area of a parallelogram. You're overthinking it. If this side is A, class, how big is that side? A. And if this side's B, how big is this side? B. So 2A plus 2B. It's kind of like 2 lengths and 2 widths, but they're not technically called lengths and widths. They're just sides. So these 2 sides and these 2 sides added together gives perimeter. What about for a triangle? If I know the 3 sides of a triangle at number 22, how do I find the perimeter, class?
1/2.
Perimeter, distance around a triangle.
And just add them all together.
Add the 3 sides, A plus B plus C. Just add them together. What about for a square? If we know one side of a square, how do I find the perimeter?
Multiply by 4.
Multiply by 4, right? Because there's 4 sides. For a rectangle, I know the length, I know the width. How do I find the perimeter? 2L plus 2W. A trapezoid. Ooh, trapezoid. Picture that for a second. They give me all 4 sides. How do I find the perimeter? Just add them all together. Remember, perimeter, just add up all the sides you got. Now, again, for the square, they didn't give us 4 sides. They gave us 1 because all 4 were equal. For the parallelogram, they didn't give us all 4 sides. They only gave us 2 because we know the other 2 are equal to the first 2. Dropping down now to number 26. What do we call the measure of a shape's surface? The measure of a shape's surface. Perimeter is the distance around, but the surface itself is?
Area.
Area, good, Ben. What do we call the flat side of a geometric solid? Ooh, a solid object. What do we call one surface? Michael?
Face.
A face. What do we call the face upon which a geometric solid appears to rest? The side that the solid is resting on. What do we call that, Joel?
The bottom of it.
Well, we actually have a more technical term than the bottom of it, but that's practically speaking. Anyone?
Maybe the base.
The base. The base. What is the sum of the areas of all the faces of a geometric solid? You add the areas of all the faces and you get the, anyone?
Surface area.
Surface area. The surface area. What about if we only add the vertical faces of, say, a rectangular prism? We don't add the top and bottom, just the vertical faces. Now we're dealing with something called, class? Lateral surface area. It's the surface area of the sides, so to speak. What do we call the content or the capacity? How much a geometric solid can hold, class?
Volume.
Volume. What is a rectangular prism, picture it, with 6 square faces?
Cube.
A cube. What do we call a geometric solid with a circular base and a vertex?
Cone.
A cone. What about a geometric solid with 2 circular bases and a curved lateral surface?
Cylinder.
Cylinder, good. Let's flip over now to page 507. And, or look across the page, rather, page 507. And they ask for the areas. Again, we're not going to take time to work these, but if we wanted to find the area of a rectangle in 38, what's my formula for the area of a rectangle, class? A equals LW. Write that down. Just write that formula down next to 38. What about 39? The area of a triangle.
A equals 1/2 BH.
Good, a half BH. So remember, on a problem like 39, you cut one of those 2 numbers in half first. Obviously, which one's easier to cut in half, class? The base, the 12, right? Cut that in half to get 6, then multiply. What about for number 40, the area of a square?
4s.
A little careful, that's perimeter.
S squared.
A equals S squared. You're going to multiply side times itself, 16 times 16. What about for a parallelogram in the next one? A equals?
VH.
VH. It's kind of like the rectangle. You just multiply the two dimensions. Parallelogram, just multiply the two dimensions. Circle. Here you go, Michael. What's the formula for the area of a circle?
Pi r squared.
Pi r squared. A equals pi r squared. So we'd square the 8 first to get class
64.
64, then multiply by 3.14. And the trapezoid does have a rather interesting area formula. It doesn't have a cool perimeter formula, you just add up the sides. But the area formula of a perimeter is kind of obnoxious. Jalen?
A equals 1/2 AH times the quantity of the 1 plus the 2.
Good, remember here we have to add the two bases first, and then either cut the sum of the bases in half, or cut the height in half. You don't cut the individual bases in half, but here, is the height easy to cut in half, class?
No.
That's a pain. What if you add the two bases together? What do you get?
27.
27. Is that easy to cut in half?
No.
Dadgummit. Okay, in that case, I'd probably multiply 9 times 27 and just wait till the end to divide by 2, since nothing's easy to cut in half. That's how we'd work those area problems. Look at number 44. Surface area of a rectangular prism. If we were wanting to find the surface of a box, I've got a box over there, I'm too lazy to go grab it. But if we wanted to find the surface area of a box, well, there's two sides, two ends, a front and a back, and a top and a bottom, right? But it also has a length, a width, and a height. To find the surface area, it's kind of a long formula, not a hard formula, but a long formula. Say it with me, class. SA equals 2LW plus 2LH plus 2WH. Now, by the way, these three things could be in any order, right? Because addition is commutative. So you could put the 2WH here, the 2LH there, doesn't really matter. Basically, just multiply the dimensions together. So you'd multiply length times width, double it. Multiply width times height, double it. Multiply length times height, double it. Add those all together for the surface area. But what if you wanted the lateral area? Didn't ask for it, but which of these do we chop off for a lateral area?
The width and height.
The 2LW, because remember, length times width is the bottom or the top, so we just chop that off. So it's the rest of it. What about volume? This is actually really easy. The volume of a box, class?
No, just LWH.
LWH, multiply them all together. LWH, mash them all together. Length, width, height, just multiply it all. For a rectangular prism. Cylinder was really obnoxious. Cylinder was obnoxious because, remember, for the surface area of a cylinder, you have a circle at the bottom. Well, what's the area of a circle, class?
Pi r
Pi r squared, but you've also got a circle at the top, so it's 2 pi r squared. Plus, you have the rectangle that wraps around like the label on a can, which has a circumference, which is 2 pi r, times height. So plus 2 pi r h. Write that down next to number 45. You have two circles, so that's 2 pi r squareds. And you have a circumference times height, length times height, base times height for the rectangle, so to speak. The volume, by the way, lateral area is just that missing. It's just that part. And then for the volume, remember the volume is the area of the bottom times the height. Just like it's area of the bottom, length times width, times height. Well, what is the area of the bottom of a cylinder?
2 pi r.
Just pi r squared, right?
Pi r squared.
Times height. So pi r squared times height. Those are your three formulas for the cylinder. Make sure you have all three of those written down for 45. Have those written down next to number 45. And again, you plug in the numbers, do the math. But for sake of time, we won't. If you know the formula, you know how to plug in numbers and solve. Go ahead. For the cube. Well, a cube is just a box, right? But the cube, all the sides are the same, right? So instead of having a length and a width and a height, we just have an edge or a side, right? They use the letter S. But, so we have the area of one side would be side squared, but there's 6 of them. How about 6s squared? For the surface area, right? Every surface is a square, so areas have squares, side squared, but there's 6 different squares on a cube, correct? So 6s squared. Lateral area. Well, if you ignore the top and bottom, there are how many squares on the sides?
4.
So it's 4s squared, or 4e squared, I believe might be the formula we used earlier. What about the volume? Well, it is length times width times height. It just happens that it's side, side, and side. So side cubed or edge cubed. E cubed is actually the way we put it earlier, but we're using their lettering for number 46. That's what we put it down. Make sure you have these copied down next to your problem number 46. Again, for sake of time, we won't actually work it. The cone doesn't have a surface area formula. It's way too convoluted. We didn't have a lateral surface formula. We did have a volume formula for the cone. And we said because a cone comes to a point at the top, the cone is 1/3 of a cylinder. So just put this next to the cone, 1/3 pi r squared h. 1/3 pi r squared h. And you copied those formulas last night for homework, just giving you a quick recap here on formulas here as well. Number 48 to 59, that little section, we won't take time to work all of these, but we're just converting measures. 2 key rules to remember, class. If you're going from larger to smaller,
Multiply.
say that with me. Larger to smaller, multiply. But if you go from smaller to larger, we divide. Now we don't fly like an airplane, it's a division sign, it's a fraction bar. Okay, but, or you could, anyway. So smaller to larger, class, divide. Say that with me. Smaller to larger, divide. Again, smaller to larger, divide. So on number 48, going from ounces to pounds, multiply or divide, class? Divide, because ounces are little, pounds are big. We would divide by 16 because there's 16 ounces in a pound. Number 49. Oh, we don't need to think larger to smaller, smaller to larger. That's metric. For metric class, we just need to remember one pseudo-historical fact. Volunteer for the pseudo-historical fact. Bryson?
King Henry died unexpectedly drinking chocolate milk.
Say that with me, class. King Henry died unexpectedly drinking chocolate milk. Now remember for the die to put a little A with it for deca. But we just boink from wherever we are. So for instance, on number 49, let's actually do this one. We're starting with what unit, class? Well, what meters, right? Meters, which is the unit. And we're trying to boink our way to millimeters. Are we going from meters to millimeters? Well, here's meters, the actual unit, and we're boinking our way to millimeters. So we got to track our direction. Go do it with me, class. Boink, boink, boink. End with an arrow. It tells you not just how many places to move the decimal, but where to move it. Now, go to the 0.0258 that they gave you and do the same thing, going that direction. Boink, boink, boink. What do we get for our answer, class?
25.8.
25.8. Number 50, bushels to pecks. Is that larger to smaller, smaller to larger? Large bushels to small pecks, we should by how many? 4 pecks in the bushel. Number 51, larger to smaller, smaller to larger? Small pounds to huge tons, we divide by 2,000. Number 52, feet to inches. Larger to smaller, so we multiply by 12. Hand motions help. Number 53, seconds to minutes.
Smaller to larger.
We divide by 60. Number 54, miles to feet.
Larger to smaller.
Larger to smaller, we multiply by
5,280.
5,280. Oh, number 55. We're going from, this is metric now, from milliliters to hectoliters. Class, start by putting a dot under the M, the milk. And then we got to boink our way all the way to the H, the hecto, the Henry. 1, 2, 3, 4, 5 boinks that way. Underneath your decimal. Boink, 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 boink. What do we have to put in for those last 2 boinks, class? 0. So you should have 0.00571 hectoliters. At your seats, 256. 256 at your seats. Going from kilo all the way, not to deca, not the first D. You're going to the next one, the drinking, not the die. 1, boink, boink, boink. 4 boinks that way gives us what for our answer, Luciana?
326,000.
326,000. The first boink is the 6, and there's 3 more 0 boinks we got to fill in. How many of the 326,000 there? 18 weeks to days, class. We are going from we by teaspoons to tablespoons. We should divide by 3. And quarts to gallons. We should by turn the page. Number 60. We're going to do this together real quick. To add compound measures, remember, you just add them up. Don't make it hard. Add up all the inches. Call it out. 22 inches. And then add up all the feet. 19 feet. But, so that's just addition. Don't make that hard. But we don't leave the answer like this. Because how many inches does it take to make another foot?
12.
How many 12s do I have?
One.
Only one. I'm close to a second 12, right? But I only have one 12. So take away 12 of the inches to leave me with 10 inches. And these 12 inches I took away add on as one extra foot. So we get
20 feet and 10 inches.
20 feet, 10 inches. Jump over to number 62 with me very quickly. I just subtract, right? 10 pounds or 21 pounds, 10 ounces, minus 12 pounds, 14 ounces. No big deal. Just subtract, right? Wait a second. Can I take 14 ounces from 10 ounces? I don't have enough ounces, so I got to borrow from the 21. Make it a 20. And that 1 pound I'm borrowing, class, has to turn into how many ounces? 16 more. Now, I already had 10 here. So if I add on an extra 16 ounces, I really have how many ounces over here now, class? I really have 26 ounces. Now I subtract to get 12 ounces, and over here, 8 pounds. Dropping down to number 63. Look at number 63. We just multiply. Don't make this hard. Just multiply by 7. 7 times 2, class? 14 quarts, no big deal. 7 times 9? 63 gallons. It's a lot of gallons, but the math isn't that bad, except, like addition, you can't leave the answer like this. Not if you could make a bigger unit. And we can, right? Because it only takes how many quarts to make a gallon, class? 4. Well, I have 4. In fact, I've got how many 4s?
3.
I've got 3 sets of 4s. How many total quarts is that?
12.
12 quarts I'm taking away to leave me with only 2 quarts. But those 12 quarts become how many extra gallons over here? They turn into 3 additional gallons to give me
66 gallons.
66 gallons, 2 quarts. Okay, make sure you've got that done with me there. And then look at number 64 right after it. We've got 52 gallons and 2 quarts. And they want us to divide by 6. Well, no big deal. We just divide. How many times 6 go into 52, class? 8 times. Because 8 times says 8 gallons. Because 8 times 6, class, is 48. So we subtract the 48 gallons. But I have leftovers, right? I still have how many gallons sitting here? 4 gallons. I don't want to just have 4 gallons sitting there. And there's not enough quarts to do anything with on its own. So now let's make those 4 gallons turn into quarts. How many quarts in a gallon? 4. So 4 gallons turns into 16. But I already had 2 quarts up here. Now I just made 16 more quarts. So really, class, how many quarts I got? 18 quarts. Now we can divide the 18 by the 6 to get 3 quarts. And there's our answer there. So just a quick crash course review in this. If you need to go back earlier in the book, I believe this is way back in chapter 6, if I'm not mistaken. You can look through that and work through those things there. Your homework for this evening is to do pages 504 to 505. Pages 504 to 505. The homework section 1 to 17. Pages 504 to 505, the homework section. Doing numbers 1 through 17. This will give you a good review of some basic stuff way back from the earliest part of the year. We just need to refresh our memory on, so we'll go over this first thing tomorrow. Page 504 to 505, homework section 1 to 17. Don't forget our exam will be tomorrow. That's coming up in lesson 178. For those watching on YouTube, we have a review time right before the exam, so both lessons will be recorded in the same day. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.